Dear students, ਅੱਜ ਦੇ ਐਪੀਸੋਡ Qualitative and Quantitative Analysis of Organic Compounds ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ Qualitative Analysis ਦਾ ਕੀ ਮਤਲਬ ਹੈ? ਕੈਮਿਸਟਰੀ ਵਿੱਚ ਇਸ ਦਾ ਮਤਲਬ ਹੈ ਕਿਸੇ ਸਬਸਟੈਂਸ ਜਾਂ ਮਿਕਸਚਰ ਨੂੰ ਉਸਦੇ ਕੈਮੀਕਲ ਕਨਸਟੀਟਿਊਐਂਟਸ ਜਾਣਨ ਲਈ ਟੈਸਟ ਕਰਨਾ। Do you know the meaning of quantitative analysis? The word quantity means that we are talking about weights. This means that quantitative analysis refers to the determination of how much of a given component is present in a sample. Today, we will discuss about methods of determining various types of elements present in compound and their percentage. Whenever we synthesize any compound, we just have an idea of compound and its exact composition is unknown to us. There are a number of different chemical tests through which we get to know about various elements present, and this analysis of elements is called qualitative analysis. Similarly, in order to find empirical and the molecular formula of compound, we must know percentage of various elements present in a compound. For calculating the percentage, various methods of quantitative analysis are present. ਕੀ ਤੁਹਾਨੂੰ ਇੰਟਰਸਟਿੰਗ ਲੱਗ ਰਿਹਾ ਹੈ? ਪਰ ਅੱਗੇ ਵਧਣ ਤੋਂ ਪਹਿਲਾਂ ਮੈਂ ਤੁਹਾਡੇ ਨਾਲ ਅੱਜ ਦੇ ਲੈਸਨ ਦੇ ਲਰਨਿੰਗ ਆਬਜੈਕਟਿਵਸ ਡਿਸਕਸ ਕਰ ਲਵਾਂ।
Upon completion of this topic, the learner will be able to discuss qualitative and quantitative analysis. Write chemical reactions involved in qualitative analysis of organic compounds. Understand principles involved in qualitative analysis of organic compounds.
So now we know that any unknown compound can be analyzed by two different methods known as qualitative analysis and quantitative analysis. Let us now discuss both these analyses one by one. Let us first discuss qualitative analysis. As we know, organic compounds are mainly composed of carbon and hydrogen. Both these elements can be detected through a number of tests. Let us first learn about detection of carbon and hydrogen. For detection of these two elements, the given compound is heated with copper oxide. Carbon present in the compound is oxidized to carbon dioxide and hydrogen is converted to water. The carbon dioxide, that is CO2, so obtained is passed through lime water which develops white turbidity. Similarly, hydrogen obtained is detected by white colored anhydrous copper sulfate which turns blue with water. Various reactions involved in both these tests are as shown on the screen. Carbon reacts with copper oxide to form copper and carbon dioxide. C plus 2CuO gives 2Cu plus CO2. Carbon dioxide reacts with calcium hydroxide to form calcium carbonate and water. This means that CO2 plus CaOH whole twice to form CaCO3 plus H2O. Hydrogen combines readily with oxygen to form water. It will react with many metal oxides to remove the oxygen and form the free metal. Hydrogen reacts with copper oxide to form copper and water. H2 plus CuO gives Cu plus H2O. Anhydrous copper sulfate, which is white in color, combine with 5 molecules of water to form hydrated copper sulfate, which is blue in color. 5 molecules of water attached to it are called water of crystallization. The equation can be written as CuSO4 plus 5H2O to form CuSO4 dot 5H2O. Children, Do you know that for detection of other elements, sodium extract or Licinie's extract of compound is to be prepared, and the tests are to be performed on this extract to know about the identity of element present.
Let us now learn about preparation of sodium fusion extract or Licinie's extract for detection of elements. For preparation of this extract, 1/4 pea-sized dry sodium metal dipped in kerosene is taken out and dried between folds of filter paper. It is then transferred to bottom of an ignition tube. Notice its position in the ignition tube. It is then heated in a fusion tube till it turns to a shining globule. Then a pinch of organic compound is fused with it. When the tube becomes red hot, it is plunged into 8 to 10 ml distilled water. This process is repeated 2 to 3 times. The solution so obtained is boiled and filtered. The filtrate is Licinie's extract or sodium extract. Can you now predict what can be the purpose of preparing this extract? The purpose of preparing this extract is to convert nitrogen, sulfur, halogens and phosphorus in covalent organic compound to ionic compounds with sodium. With sodium, nitrogen, that is N, sulfur, that is S, and halogens give sodium cyanide, that is NaCN, sodium sulfide, that is Na2S, sodium halide, that is NaX, and if both sodium and sulfur are present together in a compound, we get sodium thiocyanide, that is NaCNS, which are all ionic inorganic compounds. Let us have a look at the equations on the screen. Sodium reacts with carbon and nitrogen to give sodium cyanide. Sodium reacts with sulfur to form sodium sulfide. Sodium reacts with halogen to form sodium halide. Sodium reacts with carbon, nitrogen and sulfur to form sodium thiosulfide.
Students, आओ हुण detection of nitrogen बारे जानिए. These are two different tests by which presence of nitrogen in a compound can be detected. Let us learn about them one by one. Let us first learn about Licinie's test. In this test, 1 to 2 ml of sodium extract is heated with 1 to 2 ml freshly prepared solution of ferrous sulfate, that is FeSO4, and is then acidified with dilute hydrochloric acid. It is then heated and a few drops of ferric chloride are added. Appearance of green or blue color known as Prussian blue color confirms nitrogen in the compound. Let us have a look at the chemistry involved in this test, shown on the screen in the form of the equation. Sodium cyanide reacts with ferrous sulfate to form ferrous cyanide and sodium sulfate. Excess of sodium cyanide reacts with ferrous cyanide to form a complex called sodium ferrocyanide. Excess of sodium ferrocyanide present reacts with ferric chloride to form ferric ferrocyanide, which is blue in color along with sodium chloride. In this test, concentrated sulfuric acid can also be used, which oxidizes some of ferrous ions to ferric ions, which combine with ferrocyanide ions to form Prussian blue colored ferric ferrocyanide. Sometimes in this test there is formation of blood red coloration. This happens when in a compound there is presence of both nitrogen and sulfur. Sodium thiocyanide plus ferric chloride gives ferric thiocyanate and sodium chloride. Ferric thiocyanate formed is blood red in color. This test is not given by hydrazine as it does not contain carbon.
Detection of nitrogen in an organic compound. ਇਸ ਨੂੰ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝਣ ਲਈ ਇਸ ਐਨੀਮੇਸ਼ਨ ਨੂੰ ਵੇਖਦੇ ਹਾਂ. You see on the screen that materials required for this experiment are ferric chloride, concentrated hydrochloric acid, ferrous sulfate and Licinase extract. Let us now have a look at the procedure. We take approximately 2 ml of Licinase extract in a test tube and add approximately 2 ml of freshly prepared ferrous sulfate to it. We next boil the contents over a burner for some time. Next, we add few drops of ferric chloride solution to it. Few drops of concentrated hydrochloric acid are then added to it. A Prussian blue color is formed. Let us now have a look at the observations in the form of a table. Observation table. Test tube. Reagent added. Ferrous sulfate plus ferric chloride plus hydrochloric acid. Observation. Prussian blue color. Inference. Nitrogen is present.
We will next learn about detection of sulfur. Presence of sulfur in a compound can also be detected by two different tests as we will discuss just now.
Detection of sulfur in an organic compound. The first one is Licinase test. In this test, the Licinase extract is treated with sodium nitroprusside solution which gives violet coloration. From the color of solution, sulfur is detected. The chemistry involved is as shown on the screen. Na2S plus Na2FeCN5NO gives Na4FeCN5NOS, which is of violet color. Let us now discuss the lead acetate test. In this test, the Licinase extract of compound is treated with lead acetate solution in presence of acetic acid. There is formation of black precipitate of lead sulfide which confirm the presence of sulfur in compound. The chemistry involved is as shown on the screen. Na2S plus PbCH3COO whole twice gives PbS, which is of black color, plus 2CH3COO Na. Have a look at the chart. The reagents added are acetic acid plus lead acetate. Observation is a black precipitate and inference is sulfur is present.
We will now discuss about detection of halogens. Halogen present in a compound and its type can be detected by any of the tests which we will discuss right now. The first one is Licinie's test. In this test, first extract is boiled with concentrated nitric acid followed by addition of silver nitrate solution. There is appearance of white precipitate of silver chloride. If chlorine is present in a compound, Similarly, there is formation of dull yellow precipitate of silver bromide if bromine is present in a compound, or bright yellow precipitate of silver chloride if iodine is present in the compound. The chemistry involved in this test is shown on the screen. Silver nitrate reacts with sodium chloride to form sodium nitrate and silver chloride. Concentrated nitric acid is used to destroy any sodium cyanide or sodium sulfide if present in extract, as otherwise a white precipitate of silver cyanide or black precipitate of silver sulfide will also be obtained, which can create confusion in this test. Sodium cyanide reacts with nitric acid to form sodium nitrate and hydrogen cyanide. Sodium sulfide reacts with nitric acid to form sodium nitrate and hydrogen sulfide. आओ हुण layer test for bromine and iodine in compound बारे जानिए. In this test, after boiling a portion of extract with concentrated nitric acid, a few drops of carbon tetrachloride or chloroform or carbon disulfide are added, which form a separate layer and is shaken with chlorine water. Appearance of violet color in the organic layer confirms iodine, while orange color confirms bromine. Sodium bromide reacts with chlorine to form sodium chloride and bromine. Sodium iodide reacts with chlorine to form sodium chloride and iodine. We will now learn about Bilstein's test. In this test, a clean copper wire is heated in non-luminous flame till it does not give blue or green color to flame. The hot end is now touched with the organic compound and again heated in non-luminous flame. Reappearance of blue or green color shows the presence of halogens. Type of halogen cannot be detected by this method. Urea, thiourea and some other non-halogen compounds also give this test. Children, we will now learn about detection of phosphorus. A pinch of given compound is fused with Na2O2. The phosphorus present in the compound is oxidized to phosphate. The solution is then boiled with nitric acid and then treated with ammonium molybdate. A yellow coloration or precipitate indicates the presence of phosphorus. Phosphorus in organic compound gives sodium phosphate. Sodium phosphate reacts with nitric acid to form phosphoric acid and sodium nitrate. Ammonium molybdate reacts with phosphoric acid and nitric acid to form NH4 whole thrice, PO4, 12, MoO3 and ammonium nitrate and water. We will now learn about quantitative analysis. The amount of an element present or its percentage in compound can be calculated by the methods mentioned on screen. Let us now learn about the first one, that is, estimation of carbon and hydrogen. In this method, a known weight of the given organic compound is strongly heated with dry copper oxide. The carbon present in compound is quantitatively converted to carbon dioxide and water. Weight of carbon dioxide, that is CO2, obtained is determined by absorbing it in aqueous solution of potassium hydroxide, while that of water, that is H2O, by absorbing it in anhydrous calcium chloride. From the weight of carbon dioxide and water obtained, percentage of carbon and hydrogen can be known. Let us try to calculate it. Let weight of compound is W grams and weight of carbon dioxide is WCO2 grams. Then 44 grams of CO2 is equivalent to 12 grams of carbon. Grams of carbon dioxide is equivalent to 12 divided by 44, which is then multiplied by weight of carbon dioxide in grams. W grams of compounds contains C is equal to 12 divided by 44 multiplied by weight of carbon dioxide. Therefore, 100 grams of compound contains carbon equal to 12 divided by 44 multiplied by weight of carbon dioxide divided by the weight of compound, which is then multiplied by 100. So, the percentage of carbon will be equal to 12 divided by 44 multiplied by weight of carbon dioxide divided by weight of organic compound multiplied by 100. Similarly, percentage of hydrogen is equal to 2 divided by 18 multiplied by weight of water divided by weight of organic compound multiplied by 100. Let us now learn about estimation of halogens. When a known weight of the given organic compound is heated strongly with fuming nitric acid and silver nitrate, that is HNO3 and AgNO3, in a carrier's tube of length 50 centimeter. The halogen present in compound is quantitatively converted to water insoluble silver halide. The silver halide obtained is washed, dried and weighed. From the weight of silver halide obtained, percentage of halogen present can be calculated as follows. Percentage of halogen is equal to A divided by 108 plus A, which is then multiplied by weight of silver chloride divided by weight of compound, which is again multiplied by 100, where A is the gram atomic weight of halogen, that is, chlorine is equal to 35.5 grams, bromine is equal to 80 grams, and iodine is equal to 127 grams. We will now learn about estimation of sulfur. A known weight of the given organic compound is heated strongly with fuming nitric acid and barium chloride in a carrier's tube. The sulfur present in the compound is quantitatively converted to water insoluble barium sulfate, that is BaSO4. The precipitate of barium sulfate is washed, dried and weighed. From the weight of barium sulfate, that is BaSO4, obtained percentage of sulfur can be known as shown on the equation. Percentage of sulfur is equal to 32 divided by 233 multiplied by weight of barium sulfate divided by weight of compound multiplied by 100. Children, now we will learn about estimation of phosphorus. Let us try to find out how this is done. A known weight of the given compound is strongly heated with fuming nitric acid to convert all of the phosphorus present quantitatively into phosphoric acid. The resulting phosphoric acid is converted to magnesium ammonium phosphate, that is MgNH4PO4, which is a white precipitate by reacting with magnesia mixture. Magnesia mixture consists of aqueous NH4Cl plus MgCl2 plus NH4OH. The precipitates are washed, dried, ignited to get Mg2P2O7, which is weighed. Let us have a look at the equation present on the screen. Percentage of phosphorus is equal to 62 divided by 222 multiplied by weight of Mg2P2O7 divided by weight of the compound multiplied by 100. Estimation of nitrogen. The percentage of nitrogen present in a given organic compound can be estimated by Dumars method. A known weight of given organic compound is heated strongly with copper oxide, that is CuO, in the atmosphere of carbon dioxide in order to convert all the nitrogen present in compound into nitrogen gas. The gaseous mixture of carbon dioxide plus water plus nitrogen is passed through aqueous potassium hydroxide solution to collect nitrogen gas. Its volume is calculated at STP, and from the volume of nitrogen collected, percentage of nitrogen can be estimated as follows. Let the weight of organic compound be W grams and volume of N2 at STP be Vn. Then 22,400 cc of nitrogen at standard temperature and pressure is equal to 1 mole or 28 grams. 28 divided by 22,400 multiplied by volume of nitrogen at standard temperature and pressure is equal to 28 divided by 22,400 multiplied by volume of nitrogen. Therefore, W grams of compound has nitrogen equal to 28 divided by 22,400 multiplied by volume of nitrogen. 100 grams of compound has nitrogen equal to 28 divided by 22,400 multiplied by volume of nitrogen divided by weight of the organic compound. This is then multiplied by 100 to get the percent composition.
Let us summarize different methods of quantitative and qualitative analysis of organic compounds. Relations for the estimation of elements in organic compounds. Percentage of carbon is equal to 12 divided by 44 multiplied by mass of carbon dioxide formed divided by mass of the compound multiplied by 100. This is according to Lebig's method. Percentage of hydrogen is equal to 2 divided by 18 multiplied by mass of water formed divided by mass of the compound multiplied by 100. This is also according to Lebig's method. Percentage of nitrogen is equal to 28 divided by 22400 multiplied by volume of nitrogen at NTP divided by mass of the compound multiplied by 100. This is according to Dumars method. Percentage of nitrogen according to Geldahl's method is equal to 1.4 multiplied by normality of the acid used multiplied by volume of the acid used divided by mass of the compound. Percentage of halogen, that is X, according to Carrier's method is equal to gram atomic mass of X divided by 108 plus gram atomic mass of X multiplied by mass of AgX formed divided by mass of the compound multiplied by 100. Percentage of sulfur according to Carrier's method is equal to 32 by 233 multiplied by mass of BaSO4 formed divided by mass of the compound multiplied by 100. Percentage of phosphorus according to Carrier's method is equal to 62 divided by 222 multiplied by mass of Mg2P2O7 formed divided by mass of the compound multiplied by 100.
Now that we have learnt so far, let me ask you few questions to check your understanding. Bellstein's test is used for detection of chloride, bromide, iodide, all of these. The correct answer is all of these. Next question is, Lebesgue's method is used for estimation of carbon, hydrogen, both carbon and hydrogen, nitrogen. The correct answer is both carbon and hydrogen. The next question for you is, in organic compounds, phosphorus is estimated as Mg2P2O7, red phosphorus, Na3PO4 or Ba3PO4 whole twice, and the correct answer is Mg2P2O7. Here's my next question. Organic compounds are fused with sodium metal in Licinie's test in order to increase the ionization of the compound, increase the volume of the compound, increase the reactivity of the compound, or convert the covalent compound into a mixture of electrovalent compounds. And the correct answer is convert the covalent compounds into a mixture of electrovalent compounds. My next question for you is, in Licinie's test for the detection of nitrogen, the blue color of the solution is due to the formation of ferric ferrocyanide, potassium ferrocyanide, sodium ferrocyanide, or sodium cyanide. And the correct answer is ferric ferrocyanide. My next question is, for the detection of sulfur in an organic compound, sodium nitrotrucide is added to the sodium extract. A violet color is obtained, which is due to the formation of the complex Na4 in bracket Fe CN5 NOS, Na3 in bracket Fe CN6 Fe CNS whole thrice, Na3 in bracket Fe CN5 NS, and the correct answer is Na4 in bracket Fe CN5 NOS. The next question is, concentrated nitric acid is added to Licinie's filtrate during the detection of halogens in order to increase the concentration of nitrate ions, increase the solubility product of silver chloride, help in the precipitation of silver chloride, or decompose sodium sulfide and sodium cyanide if formed any during the reaction. And the correct answer is decompose sodium sulfide and sodium cyanide if formed any during the reaction. My next question is, the compound that does not give a blue color in Licinie's test is aniline, glycine, hydrazine, or urea. The correct answer is C, hydrazine, because it does not have carbon. My next question is, catalyst used in Geldahl's method for the estimation of nitrogen is sodium, magnesium, mercury, or copper, and the correct answer is copper. Next question, in the sodium fusion test for organic compounds, the nitrogen of an organic compound is converted into sodamide, sodium cyanide, sodium nitrite, or sodium nitrate, and the correct answer is sodium cyanide. My next question, in organic chemistry, which one of the following elements is estimated by difference? Nitrogen, oxygen, sulfur, hydrogen, and the correct answer is oxygen. In Dumars method, nitrogen gas is collected over sodium nitrate, water, potassium hydroxide, or air, and the correct answer is potassium hydroxide. My next question is, the Victor-Meyer method is used to calculate the molecular mass of NaCl, CHCl3, C12H22O11, both B and C. And the correct answer is B, as chloroform is a volatile compound. Thank you, students, for the attention you have paid in understanding these concepts. I hope you have enjoyed the lesson as much as I have.